Here we are now at section 10.2, quadratic function translations and reflections. In this text, we're learning all of the looks of a function. We did linear, some quadratic, and others in the previous section. Well, let's begin to know and get familiar with the quadratic function. Oh, sorry. I thought I had a color, and I didn't. I had a highlighter. It is a degree 2. Well, what does that mean? Function. Well, it means largest exponent of the variable two. Um, it's often called a parabola. Parabola. Very good. So now let's look at some characteristics. That doesn't look right. Characteristics. Well, you get such as. Right, so let's make some room here so we're not crowded. We're talking about a vertex. All right, so a parabola looks like this. And there is this point right here called the vertex. And it can be either way. It can be like that, or it can be like this. Right. All right, so we're talking about reflections here. But anyway, here it's the lowest point. Here is the highest point. So a vertex, let's talk first what it is. Point of where the parabola changes directions. So let's look at that. Here it was going down, and then it changes direction and goes up. Here it is going up, and then changes direction and goes down. All right, so at that vertex point, we can determine that it is either can be the minimum value of y or maximum value of y. Okay, now we know that part. Well, what else does it have? Well, it has an axis of symmetry. This is a vertical line, that means up and down. And I need more room. That divides from the x value of the vertex. The parabola into two equal parts. It's a very important thing, isn't it? Let's see what that does to us. So if this is that, now remember I didn't draw it right, then x equals, let's say it's 1. And here we have the same thing, where x equals 1, because it's on the right side of that. And so this side and this side are equal. Of course, I drew this cattywonka, so it's not as visible as we would have on a calculator. And we're going to look at that. So we've got the axis of symmetry and a vertex. Well, what else does it have? Now, the next two can or cannot be found on the vertex, but they are a critical component of graphing. Uh, X-intercepts, and if it does cross the x-axis, there are in pairs, two of them. Y-intercept, which we understand, and that would be the value x is 0 and the y value as it crosses that axis. All right, so let's look first at a normal parabola. How would we do that? Okay, so here we have it, and we're going to talk about the parent function. And that is y equals x squared. Remember, the 2 on the variable is the highest within the terms. Of course, I only have 1. So we know it's a parabola. Okay, so we're going to make something called a t-chart, and we're going to figure out some values. So we want to try, and we know certain things that we haven't exposed you to. So we're going to try some numbers. So let's try, and they have to be kind of small. So I'm going to try -2. So if x is -2, then y is 4. All right. Let's try 0. If x is 0, y is 0. And let's try 2. And we know that's going to be 4. All right. So we have these points. And we can see now that this graph, it's a curved one, and our axis of symmetry is x equals 0. Then we know that this distance and this distance are the same. So is it true for all of the parabola? And I didn't draw very well again, but you can see now the characteristics. This is the vertex, and also the x and y intercept. And that's the only time that you'll only have one of the x values. All right. So now let's study about what they mean. So in this section right here, this is from our textbook, it has it listed as the function as some value x squared plus some value bx plus some constant. And this is called the standard form. of a quadratic. And it is very vital that you understand that you'll have an A value, a B value, and a C value that are attached to those variable or number notations. And so now we're going to look at this form. This is the vertex form. Notice that we have this condition here. And that one tells us that we have to use the opposite sign of whatever's there, and the vertex is going to be the opposite of that sign, H, comma, K. And this is a movement of that item. So H is the X value for the vertex, and the K is the Y value of the vertex. Okay. And we'll have one problem of that. What we want to get to are using our calculator. And so we're going to go now into our Y equals key. Y equals. It is the first key on our home screen. Let me turn on my calculator. Right. So we're going to clear that. Clear that. And we're going to look at this is the home screen. So I want to hit the Y equals. Once you hit the Y equals, and if you've got junk in it, clear it. All right. And you have a menu of how many lines you can insert into the computer, the calculator, but it's really a computer. It is so smart. All right. So let me put that over here. All right. And shorten it just a tad. It's a little too big. I want you to be able to see it. All right. Okay. So let me see. We're good. All right. I think you can see it. So the next thing says use the negative sign, which is on our keyboard. And we've done this before. It's way down here, way down here. I highlighted it with red. If it appears in first in the function, that it's a negative function value, the variable x is found on the second row, second key. And go to zoom key right under the menu, because that's all graphing keys, and choose number 6, Z standard. It's a 10 by 10 grid. All right, so let's look at this problem here. And we'll start it right here. Let me make it a little bit larger. So it says to match the graph without using our calculator. Well, because I got this off of the homework. Well, I wanted to use this so that you could see it on the grapher. It is an interesting thing. So we're going to get our grapher out. We're going to enter x squared, second row, second key, and the x squared key, and enter. And then on the second one, we're putting this. We're hitting the negative sign, open parenthesis, 3 minus, sorry, I didn't hit minus. Let me put this over here. My calculator. Minus x, second row, second key, close parenthesis, x squared, because that's our parabola, minus 2. All right. So we're going to hit our zoom key, as all the top ones are graphing, zoom, and we're going to hit 6 for a 10 by 10. All right. So let me look at what I did here. Sorry about that. I don't need a negative on that. I apologize. This is the parent, and this is what we see. All right, so let me copy that. So I'm going to place it right there. Okay, so we have this, right? And we want to talk about it, of course, because we want to see what took place. All right, we understand that that part right there gave us the vertex, but this guy says the x is moving in a weird way into that negative side, and the whole thing is flipped. This negative in front of 3 minus x means it's a reflection or a flip. Okay, it's a mirror image. So we know it's a flip, and we know that it is moving 3 to the positive, 1, 2, 3, and down 2, 1, 2. So this is the vertex. It is now positive 3, negative 2. And we got the negative 2 from that and the positive 3 from that. And of course, we know it's flipped. So what would we say? Okay, I would do my x, y for this function. I would start with a vertex because we know it. And we did it by a calculator. And I'm not worried about it saying don't use a calculator. So we understood that if we did a 3, we would get a negative 2. What this does is tell us, well, I can try other numbers around this one. And we could try like 0. All right. 0 would be negative 3 squared minus 2. Well, that'd be a negative 9 minus 2, a negative 11. So that would weigh way down over here, and that's true. And if we wanted, because now this is the center, and this is that end point, well, then we can do 3 more than that. So we could do a 6, and we should get 11, right? Y equals a negative 3 minus 6 squared minus 2. Yes.